value created by trade. So let's go through a numerical example so that we can get an idea of how you actually calculate this and what it means in terms of the supply and demand curves. I've been pretty abstract here as we walk through the calculating value. So let's be a little more concrete. All right, so here is an example of a market for old guitars. These Gibson L00s, L00s. Suppose this market's got 8 buyers and 8 sellers. We make it symmetric to make it easy. And each buyer has a maximum willingness to pay for one of these guitars, and each seller has a minimum willingness to accept to sell their guitar. And here is the buyer IDs and their maximum willingness to pay, B1 through 8, and the seller IDs and their minimum willingness to accept. You can see they're all over the board. Buyers range from a high of 4,000 down to a low of 500. Sellers range from a low of 500 up to a high of 5,000. All right, so that's the basic facts as we know it for this market. Now the questions that need to be answered. What's the equilibrium, market price, and quantity? What's the surplus, both for buyers, consumer surplus, sellers, producer surplus? What are the gains from trade or the value created by trade? Well, that's adding consumer and producer surplus. What's total revenue? Right? So what is the total revenue generated? That's price times quantity. And part B, does total revenue represent economic value? No, it represents financial value or accounting value, but it doesn't represent what we would consider economic value. It's a proxy for it, but it's not always a good one. All right, and then finally, number 5, suppose that the government says, hey, we can only sell one of these guitars in this market. And by restricting the market to only one sale, what's the deadweight loss to society? So to answer these questions, you can do it in 11 steps. And we're going to walk through them. Here are the steps. I'm not going to talk about them right now. I'll talk about them in order as we go. Right? But you can use this as a cheat sheet to get yourself through this. All right, so step 1, you got to draw a graph. And you want to put all the relevant values on there. So on the horizontal, you've got the 8, which represents the buyers and sellers in this market. And on the vertical, you've got the price, which ranges from 0 up to 5,000, which was the highest number of in both the buyers and the sellers. Now you want to rank order the buyers. So you can see on the left, you've got that original set of buyers, B1 through 8. And on the right part, I've rank ordered them from high to low, from 4,000 down to 500. And by rank ordering them, what you're going to do is be able to map out the demand curve as a staircase, descending staircase, that's going to start like this. So the first buyer, the maximum willingness to pay is 4,000. The second buyer, maximum willingness to pay is 3,500. And you just keep mapping these buyers down until you get this staircase. Now you have your demand curve. It looks a little different than a straight line, but a straight line is typically when you have millions of buyers and sellers and you don't have room to do this. Here we just have 8, so you can just map them out as a descending staircase. Rank order the sellers, do the same thing, except instead now you rank order them from low to high willingness to accept. Same idea, the original on the left, the ranked sellers on the right. And now you start mapping out the sellers in another staircase, except now it's ascending, going up. As you can see, the first 2 sellers, their minimum willingness to accept was 500. The third was 1,500, and you keep going until you have this supply curve. Now, you can see here that the way I've drawn it, that when you're going to calculate the market price and market quantity, it's where the supply and demand intersect. So the price is going to be at 3,000, but the quantity is going to be at 3 or 4. So this gets a little bit imprecise because you have this staircase rather than two straight lines where you have one price and one quantity. When you do the staircase like this up and down for supply and demand, you're going to get either two prices and one quantity, or in this case, which I try to do more often, is one market price and two potential quantities. And the two quantities just means that that fourth buyer, they're indifferent between buying or not because neither of them really gain, but as we'll see here in an example. All right, calculate the consumer surplus. All right, so as we see this, looking at this graph here, we see that there are 4 sales, 3 to 4 sales. So let's just look at, assuming we've got 4 sales, the maximum. So we can see that the people who are going to buy are the people on the left of Q star. So the maximum willingness to pay was 4,000 minus the market price 3,000 for buyer 1, or for the first sale. The second sale is buyer 2, or it's not buyer 2. It would have been right, buyer number 4 at 3,500. You can see that would be the second one, right? So now we have consumer surplus of 1,000 plus 500. The next two buyers' maximum willingness to pay was 3,000, both of them. So there's no consumer surplus there because the market price was 3,000. So total consumer surplus in this market is 1,500. That is the value to consumers of participating in this. So the idea, again, is that their maximum willingness to pay is either greater than or equal to the market price, and so they benefit, right? And that's area A as marked here on the graph. Now calculate the producer surplus. So you take the market price of 3,000 and you subtract away that minimum willingness to accept, which was 500 for both sellers, the first two sellers, so that's 2,500 each. The third seller had a minimum willingness to accept of 1,500, so that would be 1,500 in terms of that seller. And the fourth one is 3,000, so it's 0. So producer surplus is 6,500. Again, that represents the idea that the sellers were willing to sell at a lower level. That's their minimum willingness to accept. But since the market price was 3,000, they actually benefited. This is the win-win. 1,500 for all the consumers or all the buyers, 6,500 for all the sellers or all the producers. And this represents then the seller or producer surplus is area B, and this gives us then the value created by trade. Total gains, consumer surplus plus producer surplus is 8,000. This is the win-win, and this is what 99.999% of all economists consider to be why the market is so good. Because we created a market, people came to the marketplace, those who bought gained this value because the market price was lower than their maximum willingness to pay. And the producers gained because their minimum willingness to accept was below the market price. So 8,000 is the value created by this market. That's it. It's not a big secret, but it's a little bit different than how you would traditionally think of, financial returns, price times quantity. We'll come back to that. Now, if we're going to calculate the deadweight loss, the question was, if we restricted quantity to just one, that would mean there's only one sale. And so you can see the dotted line there where we restrict it to one sale. That means everything that we gained, if we let the market operate freely, we only get a portion of it. We only get that first sale, which would be 4,000 minus 3,000 plus 3,000 minus 500. The rest of it is deadweight loss in that area I have marked. Right? So if we were to calculate that, deadweight loss, 8,000 minus this 3,500, which is what we would have gotten, or which is what we got with only one sale, producer and consumer surplus. So the deadweight loss in this market is 4,500. That's that shaded area. So you can either calculate that shaded area, which should give you 4,500, or you can calculate total gains and subtract away remaining gains, and then you have deadweight loss. All right, well, what's total revenue? That's just price times quantity. And you can see that it's either 9,000 or 12,000, depending on whether we sell 3 or 4. And those numbers exaggerate the value created by trade, the one that we're measuring as economic value, which is 8,000. So in some ways, in this case, the way I've drawn it, total revenue exaggerates the value created by trade. If we were going to say that, to use a rough proxy, because we can measure P and Q, it's going to overestimate our $8,000 by quite a bit, relatively speaking. That's it. That's how you do it. Those are the steps. So let me know if you've got any questions.